All right. So it was 2x minus y to the 6, correct? All right. And you can grade yourself. All right. Now, 2xy to the 6th. So the coefficients would be what? 1, 6, 15, 20. Now, also, I want you to try to remember this. The power is to the 6th power. There's always one more term than the power. All right. So again, I was just counting real quick. 1, 2, 3, 4, 5, 6. So there should be 7 terms. So that looks correct. All right. Now, remember that for me personally, I used to just look at x plus y and just kind of write everything in terms of x plus y. Now, some of you guys are really good at patterns. You don't have to do that. All right. You could just literally go from this step to the answer. All right. But good job, Charlie. So for x plus y to the 6th, all right. Again, you want to write x to the 6th. Now remember, x goes down and y goes what? Up. So technically this is 1x to the 6th, y to the what? That's technically what it is. All right, so if you learn to write that, then everything else is kind of simple. All right, then it would just be plus 6 what? Y to the 1st. Now, again, all right, the sum of the powers is always this number, the exponent. All right, that's something else that's kind of helpful to know. All right, but for me, it was easy just to remember one was going down and one was going up. All right, so then it's plus 15x to the, and then plus, keep going. Yeah, guys, that's pretty nice. All right. And that's how simple it is. All right. Now, once you set up that, now it's a matter of replacing every x with what? 2x, and replacing every y with what? Negative y. All right. Now, sometimes, well, again, keep in mind that y, because it's negative to an even power, is going to remain what? Positive. But if it's to an odd power, it's going to be what? Negative. That's all there is. All right. So now, again, if we replace the x with 2x, it literally is just 2x to the 6th plus 6. And then this would be 2x to the 5th. And this would be negative y plus 15, 2x to the 4th, negative y squared plus 20 times 2x cubed, negative y cubed plus 15, 2x squared, negative y to the 4th. And then plus 6 times 2x, negative y to the 5th, plus negative y to the 6th. Does anybody have any issues with that? All right, then it's just a matter of what? Just doing the arithmetic, right? So we know that 2 to the 6th is, so it should have been 64x to the 6th. 2 to the 5th is 32. 32 times 6 is negative 192, x to the 5th, y. And then this would be plus 240 x to the 4th, y squared. And then this would be minus, Thank you. Keep going.
Plus 60x squared y to the fourth.
Keep going.
Minus 12x
And then,
plus y to the sixth.
yeah, guys, I really don't think it's that hard. All right, it really isn't that hard. All right, but for the average person, that's like a nightmare. All right, and it ends all just patterns. As you get higher up in math, a lot of the information is just understanding patterns. It looks difficult. All right, and that's why you want to understand what we're doing, not try to memorize that process. All right, it's very easy. All right, is anybody struggling with that? Anybody? All right, what was the other one that I asked you to do? 3x plus 2y to the fifth. All right, so I'm not going to write that out. I will write the answer. So it's 3x plus 2y to the fifth. All right, anybody pretty confident in their answer? All right, Brady. Shh, loud and proud. Take your mask off. I don't want to hear you stuttering.
X to the fifth plus 162x to the fourth y plus 1080 x to the third y squared plus 720 x squared y to the third plus 240 x y to the fourth plus 32 y to the fifth.
Anybody else get that? Almost? You got it?
I got 810.
810.
Yeah, I got 810.
810 instead of what?
162.
Thanks, Brady.
No, hold on.
I got 405. Yeah, I got.
Is it 162 or 810?
810. 810. No, 160.
All right, so Brady made a mistake. Mark it down in history.
No, hold on.
Oh, he doesn't believe you're wrong, or he's wrong.
How do you do it?
Lorenzo, what is wrong with you? You belong in my 7th grade class. That's what those boys are still doing.
Yep.
Seriously.
That's the best.
Can you go back to the last question?
What are we doing on the last question?
Wait, how do you do it?
It's 81
Yeah,
times
no,
2
we did
times
ourselves.
5.
I don't know how to do it.
Take a picture of it.
Okay, I got it.
They know fast.
Oh, I know.
I got 162.
Are we still saying it's 162?
No,
81 times 2 times 5.
it's 81.
It's what?
It's whatever it is.
810.
Yeah.
I know, it's hard to admit you make a mistake. All right, I know the feeling. Everybody's happy with that. Does everybody agree? It's not really that difficult. Pascal's triangle, if I said write Pascal's triangle, you could do that. All right, any issues? All right, so today we are going to do long division. All right, now, again, the long division, generally, it's, again, super easy. And I'm going to try to show you long division, and then I'm going to try to show you synthetic division. Of course, synthetic division is the way to go because it's the easiest. All right. But what I would like you to do is make yourself add a page here, please, in between so we can get started. All right. Now, generally what happens when I start with long division, when I used to teach my high school kids these long division problems, I would remind them how to do long division because you haven't done it since probably 3rd grade. All right. So again, I always try to show kids the process of long division in 3rd grade is the same process now. All right. We're just using what? Variables. That's the difference. All right. So just as a quick review, if I said, for example, 13 into like 2, 7, 9, 8, 1. All right. You would say, how many times does 13 go into 27?
Twice.
Okay. Now, the property now is you're just multiplying 2 times 1 and 2 times 3. All right. So that would be 26. Now, what did you do? You subtracted. So this was negative and that was negative, so to speak. All right, so when you subtracted, that became a 1, and then you brought down a what? 9. Then you did the same thing. You divided 19 by 13. All right, and that was 1. All right, then you multiplied 1 times 1, 1 times 3. Then you subtracted. Now notice I'm putting the subtraction here, and everything I'm doing is to help you with the long division with variables. All right, so then this is 68 and so on. All right, and let's just end it at the 8. All right, so how many times? That would be 5. So that'd be 65. You subtract again, you would get 3. And so the answer would be 215 and 3 over 13. That's how you used to do it. All right, that was the long division. All right, well, obviously now, all right, there's going to come a time where you're just dividing a trinomial by a binomial. All right, so here's how we're going to do that. All right, and again, it's very simple. All right, so we're going to set it up. We're going to set it up as a division. So it'll look like this. Except I technically don't need the parentheses. All right, now again, it's really, really simple. All right. So the first thing we're doing is we always take the first number inside and the first outside, and you're literally just dividing. X squared divided by X. What is that? X. Brilliant. Now, the X doesn't go over the X squared. It goes over the X. So I put an X right here. Then the same principles apply. You multiply. So what's X times X? And then X times -4. And this is what I was trying to show you before. Now we have to do what? We have to subtract. All right. Now for me, as always, everyone forgets when you're subtracting both. So I used to make my kids put a change of sign. And so then it becomes 5x minus 17. And again, it's just the first number divided by the first number. So now it's what? 5x divided by x, which is just what? 5. So it's plus 5. Now you multiply 5x minus 20, and then we do what to the signs? Change the signs. And so you're left with what? 3. So your answer is x plus 5 plus 3 over x minus 4. Again, it's the same as what you used to do with long division. All right, nothing is different. What?
Where did you get the 5x plus 20? Oh, you got it from 5 times 2. Wait, where did you get the 20? Oh, 5x plus 20.
You just said.
All right. I thought it was-
You multiply 5 times x, 5 times 4. You with me on that?
Yeah.
Oh, wait.
All right, any questions with that? All right, long division, here we go. So now what I want to do is just do me a favor, highlight or circle 6. All right, now what we're going to do is we're going to do number 7. All right, so everybody grab number 7. Let's bring it down to the blank page. And we're going to divide this out. All right. Now, here we go. A little bit harder. All right. So now what is x cubed divided by x squared? Is everybody happy with that? So where does the x go? Yeah, over the x. So this is actually very easy, but sometimes kids make mistakes because things don't always line up perfectly. But if you think about it logically, it just makes sense. So now what's x times x squared? X cubed, and then x times -1. Where does that go? Terms go with terms, or you can't add them or subtract them. All right, is everybody okay with that? Anybody have any issues? All right, we're not putting the x with the x squared. You put the x's with the x. X squares go with x squareds. Now you draw your line underneath it. Now what am I doing? Changing the signs because we're subtracting. All right. Now, technically, if you want, but I didn't think it was necessary because I'm sure everybody understands this is just 0x squared. All right. Believe it or not, somebody asked me once, do I have to change the 0 to -0? And of course, my reply was yes, do that. All right. So now we end up with what? X squared plus 2x, and then we bring down the 2. All right, now what's x squared divided by x squared? 1. So it's a positive 1. Now you're just multiplying. When you multiply that, that becomes x squared minus 1. Draw a line underneath it, and then change the signs. So this becomes a negative, that becomes a positive. So this becomes 2x plus 3. So my answer is x plus 1 plus 2x plus 3 over x squared minus 1. Any issues? Yeah, I told you the division is easy. Yes, ma'am.
I just don't think I understand the part when you divide it through. Like after it gets to x squared is 2x plus 2, where you divide that through.
Remember, it's always the number in the first number here divided by the first here.
Okay.
Every single time. All right, every single time. And I understand your questions. That's why I tell you, I promise you, there's nothing different here at the very beginning than what we're doing here. It's just there's some variables involved. That's it. Same process. Yes.
How do you get the final answer?
How do I get the final answer?
Like from the
So how did we get 215? And this final answer was 215 and 3 over 13. This right here is this. The remainder is here. And the remainder goes over what we were dividing by.
Oh.
You see what I'm saying? And again, I hope some of you understand what I'm trying to show you is that the harder information is exactly like the easy information. All right, you just have to put the pieces together and make sure you understand that. What?
I get how you got the fraction part, but where'd you get the x plus 1 plus 3? I get the fraction part for the answer.
You don't know where this comes from?
Yeah.
What about this right here? That's the answer. If I said, for example, 9 divided by 2, that's 4 1/2. Right? Because we did 2 goes into 9 4 times. 4 times 2 is 8, subtract 1. That's the remainder. That's the denominator. This is the whole number. It's exactly the same. All right, exactly the same. All right, so I'm happy with that. All right, so now that was number, which one? 7. So try 8. All right, now let's just try 9 because, all right, it's a little bit longer.
No.
I've never heard of that before. All right, here we go. All right, now again. Okay, so now you have to remember what I told you. All right, for those of you guys who are not sure where I'm getting it, it's always what? First divided by the first. Those are the two things we're dividing. Now, I really don't feel like going off to the side and dividing that. I'm really hoping everybody here just says that's what? Is everybody okay with that being 5x squared? Anybody? All right, so then we put 5x squared. And because now we're getting better at it, all right, now you're just multiplying. So when I multiply, it becomes 5x to the fourth plus 10x cubed minus 20x squared. Now don't forget to do what? Change the signs. Minus, minus, plus. So now that becomes what? Negative 12x cubed plus 13x squared minus 39. All right, now think about what I just told you. Negative, uh-oh. So what's wrong? There's no place for it. So that's my fault. Everybody is going to erase this minus 39. And what do I have to put in there? Good. Plus 0x. All right, there's got to be a placeholder for that. And then what was the number again? 39. Minus 39. So technically, this right here should have been a 0x. All right. Now, bless you, when we divided, what did we get? Negative what? Negative 12x. Now, again, sometimes you're going to forget that that 0x is supposed to be there. So then when you get something, you go, well, there's no spot for it. Then you have to do what? Create a spot for it. All right. Does anybody have any issues with that? What, Sam? Well, what did you divide, Sam? Sam, stop. It's always the first here divided by the first here. That's the rule. Every single time you divide the first two, and that will tell you where I got that. Yes. Come on, don't be sorry, just ask. How did I get the 20x squared? Kiddo, you're just multiplying this times this, this times this, and this times this. That's all we're doing. All right, nothing to it. Now that you know that, we're going to distribute the what? Negative 12x. All right, so now when we distribute the negative 12x, we end up with negative 12x cubed minus 24x squared plus 48x. Beautiful. Now we do what to the signs? Change them. All right, now what's 24 plus 13? So now we have 37x squared minus 48x minus 39. All right, so Sam, now what? Shh. There you go. That's really simple. That's all there is to it. And so that's what? Yep, positive 37. Now just multiplying. So I get 37x squared minus 74x, and then minus 100, what is that, 48?
Yeah. Wait, what is it? Minus 7.
Yeah.
37.
37 plus 2x times 2.
Why is it negative? It's 1/4.
Oh, it should be positive. You're right. Thank you. It is positive. All right, anybody have any issues with that? Tell me, Simon.
When you bring down the 39.
Say that again.
When you bring down the 39.
Okay, so do you remember in the long division, after you divided, you always brought this one down,
Yeah. Right.
right? So you bring it down as soon as, like, after I do my subtraction, I bring down this next one, right? Make sense? Okay, so now help me out here. Change the signs. So negative, negative, positive. So I end up with negative,
122.
and then that would be plus 100 and what? So I got 109. And so my answer, all right, I don't feel like writing it all out again. Well, we can just duplicate. And then we would say plus negative 122x plus 109 over x squared plus 2x minus 4. Everybody good with that? Yeah.
So when you went from negative 12x squared, and you distributed that, how come it wouldn't be 12x to the fourth? Did you distribute it by x squared? And 12x to the third.
Are you saying x times x squared is x to the fourth?
I thought, isn't it negative 12x to the third times x squared?
Why are you saying 12x to the third? I'm multiplying, come on now, make sure you're hearing me. I'm multiplying this times this times this, and this times this.
Oh, so,
You hear me now, right?
yeah.
You make sense? All right, again, guys, I'm trying to show you just patterns, and just be careful with your arithmetic. All right, and again, the biggest mistake that's made is kids forget to change the sign when you're subtracting. Anybody have any problem with that? All right, so that's called long division. All right, so you're going to try number 10. All right, now, before we do number 10, all right, look at this, 4x to the fourth and then x, right? So what do I need to include in here? Yes, thank you for knowing that. 0x cubed plus 0x squared, and that way things will line up. All right, then it'll be easy. All right, anybody have any questions with that? All right, now the fun part. All right, the fun part is actually the synthetic division. And I still remember fascinated by this because I know there's a proof to it. I just never bothered looking up the proof and figuring it out. All right, but I'll show you something really strange. All right, now, again, this kind of fascinated me and I should have probably looked into it to figure out why it works, but watch and be amazed. All right, so now we're going to call, for some reason they call this synthetic division. All right, so obviously I don't feel like doing long division because that's just takes too much time and there's lots of room for error. All right, so now watch and hopefully you'll go, why, that's really weird. All right, so everybody, the first thing is we're going to find the 0. So what does that mean? X minus 4 equals 0. So in the box, you're going to put a 4. In the box, you're going to put a 4. All right, what in the world does that mean? All right, so you're just learning the process now. So 4 goes in this box right here. All right. Now, the coefficients go next. 1, 8, 1. Does everybody see that? Where those numbers came from?
Yeah.
The coefficients. All right, now what you do is you leave a space, put a line right there. And you'll be amazed at how fast you can do the division. Step 1, you always bring down the first number. So that's a 1. Then 1 times 4 is 4. Then you add those numbers together. 8 plus 4 is 12. Then you multiply 4 times 12. Then you add 49. All right. Now this is really strange how this works out. And like I said, I tell kids all the time, I don't even know why. And the first time someone told me that, I just said, you guys just make math up. All right. Because it doesn't make any sense to me. All right. So let me explain to you what happened. All right. So the answer to this division problem, is x plus 12 plus 49 over x minus 4. So these are the new coefficients. All right. And we're dividing by x. So I used to tell my kids, since we're dividing by x, there's always one less exponent. All right. So the x squared became a what? X. And the x became the constant. And the number became the remainder. All right. So again, I have no idea why it works, but that works every single time. All right. So I prefer what? Synthetic division. It's just much easier. What?
You get the 4 by multiplying the 1 times the 4 we got at the beginning.
Yes. Right now I'm going to show you something else kind of weird. No. All right. And I'm going to explain why you can't, or I'm going to show you when you can. All right. But no, it doesn't work for everything. It only works for linear when you're dividing by a linear. All right. So now look up here, guys. F of 4 is equal to 49. So a lot of this was used before we had calculators, right? If I want to plug 4 in here to this equation, watch. 4 squared plus 8 times 4 plus 1. What do you think that is? 49. And that's when I used to go, how in the world does that work? Right? So again, there is a proof, I'm sure, somewhere. I just never looked it up. All right. This is called the remainder theorem. It's called the remainder theorem. All right. That just means that the function value at that point is the remainder. All right. And again, that's helpful. Before we had calculators, we just type things in the calculator. All right. But I'll show you in a minute when we do a bigger problem how it's so beneficial to understand synthetic division to help you come out with the outcome. All right. Much, much easier problem. Now, someone asked me a great question about, can you always do synthetic division? Well, let's look at synthetic division. Notice the only thing we're dividing by are linear, x minus 4, x minus 2, x plus 5. Notice you'll never see x squared. So the only time the synthetic division works is when you're using, or when you're dividing by something that's linear. All right, is everybody understanding that? All right, so now let's do one a little bit harder. I will circle number 14. I'll circle number 14. So copy that. We'll bring that down over here to my blank page. Paste the image. All right. So if we're going to do number 14, you got to be real careful. What goes in the box? Thank you for knowing that. -3 goes in the box. All right, now you have to be careful. What are the coefficients? Wrong. 1, 0, -4, and 6. And of course, that's the one they generally put on tests. They leave out a term, everybody forgets the 0. All right, so if there's a missing term, you have to create that 0. All right, now if we want to do the synthetic division, all right, so bring down the what? 1, multiply, add, multiply. What is it? I'm asking a question. I said multiply. Some of you said 12. Some of you said 9. 9. Adding. 5. Multiplying. Adding. Right. Now, again, guys, brand new information. Brand new information. Everybody should be writing it down. It's a process. You'll get the process after you do it 10 times. It's really simple. Really, really, really simple. It looks complicated. It's not. All right. It's just the process. Now, if I were to divide x cubed minus 4x plus 6 by x plus 3, the answer would be what? X squared minus 3x plus 5 minus 9 over x plus 3. And if you wanted to put plus -9 over x plus 3, that's the same thing. All right, Morty.
So when you do the 9 by multiplying the -3 times -3, right?
Exactly.
So why don't you multiply the 9 times the 5 to get the 1 under the 6?
Because that's not how we do it. This is what we're multiplying. This is the number that's being multiplied.
Oh.
All right.
Okay.
That's it. That's all there is. All right. You're always multiplying by the number that's in the box. You're adding down, multiplying by the number in the box. Come on, Simon.
What are you multiplying the -3 by?
By the first number, 1. So you're multiplying these numbers and you're adding these together. So I did, and we're going to do it again. All right. You'll catch on. All right. Go.
So what if you had x squared minus 9 for the, like for the second part? Would that work out? Because it,
No, x squared isn't a linear. Right. This only works with linear. Only works with linear. All right. You have to be dividing by a line. All right. Not a parabola. All right. So now, just to make sure everybody is understanding me. All right. If I said, what's f of -3, you would tell me the answer is what? -9. All right. And to me, that was just the most bizarre thing in the world. How in the world does that work? That means if I were to plug -3 in here, plug -3 in here, and work the math out, that would be what? It would be -9. All right. The most bizarre thing, or one of the most bizarre things, in my opinion. All right. So again, let's just practice one more. All right. And then we'll call it a day. All right. So let's take a look at 17. All right. Let's take a look at 17. All right. So let's grab that. And let's do the synthetic division. Copy. All right, here we go. All right, so now everybody should be a little bit more comfortable. What goes in the box? 6. And then the coefficients. Simple as that. Nothing is missing, correct? All right, so now you just have to be careful. All right, so first thing is you always bring down the first term here. 1. Then what? 6. Then what? Then what? Then keep going. Now, does everybody understand how powerful this was? Think about it before calculators. right? If someone asks you to do 6 to the 4th minus 5 times 6 cubed minus 8 times 6 squared plus 13 times 6 minus 12, that equals -6. Isn't that weird? Right, so 6 to the 4th, I don't feel like doing. 6 cubes, not too bad. All right, but then doing the arithmetic to make sure that is correct. So the final answer worked out to be -6. All right, now, specifically, if you were asked to write out what the solution is, all right, you would say that the solution is what? X what? X cubed plus X squared minus 2X plus 1. Yeah, look, guys, that's not that hard. All right. And again, the remainder theorem, what I'd like for you to put down here is I'd like for you to say that f of 6 equals -6. So those are the two valuable information, two things that are valuable about doing this. All right. And this later on, believe it or not, will help you with your calculus for those of you guys who are going on to do some good work in math. And this is just something that's unique. All right. And like I said, I don't understand even why. Who would even think to create something like that? All right, go.
I don't really understand how you come up with that final answer of x cubed plus x squared.
You're not recognizing the coefficients, Sam. 1, 1, 1, 1, -2, -2, 1, 1, remainder. That's all it is. And we're dividing by x, right?
Yeah.
So that's how I learned that every exponent is being reduced by 1. That's how simple. Yes. Yes, so the remainder theorem just says that our remainder is our functional value at that point. Now you're making too much of it. Don't consider this is called the what? That's called the remainder. That's why they call it the remainder theorem. So that's basically saying that if I were to plug f of 6 in, the answer is going to be what? That's what the remainder. It's the solution is -6, which is the remainder. That's all it means. All right. So again, I'm trying to show you the power before. I mean, think about it. We've had calculators. They used to not have calculators. To do this work is annoying, right? So they were always trying to find little shortcuts here and there to help them with the values. All right. So again, that's just helpful in that area. All right. So again, I do think it's important to, does everybody agree the synthetic division is not a big deal, right? So again, I do think the long division is important. So let me just highlight a few things, and I want you guys to highlight these. All right. You're going to do the long division for 5. You're going to do the long division for 7 and 9. And then I don't even remember which synthetic divisions we did, but I do want you to practice all the synthetic division because that's the easier one. All right. But more importantly, the long division is something that's occurring on the SAT more. So that's why I think it's important to review that. All right. So I don't know if you've heard, but I will be doing your science class. All right. And just like when I was out, I told her she could have an extra science class. So she said I could have an extra math class. So we will just finish this up today in math or in science class. All right.
Are you have different class?
Oh wait, no, we can't do this. We're not in the same classes.
We're not missing.
Oh, trust me, we're going to do this.
Yes.
There's just going to be an algebra class in there, and I'm going to give them the same. We have an extra algebra class. They have a test tomorrow. They're going to be reviewing while you guys are doing this. Man, you guys are, man, where would I be without you guys helping me out, man? I'm not sure how I made it to all this experience, and you guys are telling me what to do, man. I am so lucky. All right.